Hey hi everyone, welcome back to our daily LeetCode challenge series. So today is day 103 and today we are going to solve LeetCode problem 160, intersection of two linked lists. Okay, so this is an easy level problem. So let's see the problem first. So we have given the heads of two singly linked lists, head A and head B. Return a node at which the two lists intersects. If the two linked lists have no intersection at all, then return null. Fine. So in the example we have given two linked list A and B, where A1 and A2 is getting intersected at C1 point, and similar B singly linked sticks is getting intersected at same at C1, and B is having three elements before getting intersected, and similar in A we have two elements before get intersected. Fine. So in example image we can see it clearly, right? So the test case was generated such that there are no cycle anywhere in the entire linked list structure. So this is for clear, like there will be no cycle at all in a single linked list, right? Note that the linked list must retain their original structure after the function returns. Fine. So we don't have to manipulate the given linked list at all. We just have to find the expected that node where basically both linked lists is going to be intersected, right? Fine. So custom judges, we have given the input of the judges are given as follow: intersect val, and the value of the node where the intersection occurs. This is 0 if there is no intersection node. Fine. List A, the first linked list. List B is the second linked list. Okay. The number of the nodes to escape ahead in list A, and escape B is the number of node escape ahead in list B. Fine. So the judge will then create the linked lists based on this input and pass the two heads, head A and head B, on your program. If you correctly return the intersected node, then your solution will be expected. So basically in the given method, like we have only access to the head A and head B, the both linked list set, right? That's what they are saying. Fine. So in example 1, similarly it is given 418545 and list B 56184. So here from image we can see from 845 this is getting intersected at the point A, right? So we are returning point A, and we are skipping 2 in first linked list, and skipping 3 elements in the second linked list. Fine. Anyways, we just have access to this head node, that's all, and we have to return the intersected value, which is 8, right? Fine. Same explanation has been given here. Let's see the example 2. In example 2, similar way we are getting intersection at point 2, so we are returning 2, and we are skipping 3 elements in an like single linked A and 1 in the B. Fine. In example 3 we can see there is no intersection, so at last we will going to return null. Fine. So constraint we have given the node of list is in the M, the node number of nodes in B is n. Fine. And M and n can vary from 1 to 3 into 10 to the power 4. Fine. Node value can also range from 1 to 10 to the power 5. Okay. And skip A and skip A will obviously within the range of that single linked list. Fine. So that's all about the question part. So like I think it's quite easy one. Basically we just have to keep iterating and check till we don't get both node at the same point, right? So let's do that part. So we have the access of these two nodes. So what we are just going to create two pointer. So let's say pointer 1, which is having the head A. Similar way, let's say list node pointer 2, which is having head of B. Okay, because anyways we don't have to manipulate the giving single list, right? That's why we have to create some temp variable, temp node. Now simply we are going to check if our P1 is not equals to P2. Till then we have to check, right? And what we have to check here is the current value should not be equal to the current pointer of A. So P1 let's say is the first linked list and P2 is the second linked list. so both nodes should not be equal. If it is equal, then we are just going to return. So at last we are just going to simple return our that node, right? So okay, p1 dot val we have to return, fine. List node we are going to return, right? Okay, so p1 just we have to return. In case even we can write p2, that doesn't matter. If it becomes same only, then we have to return, fine. Now what we have to do is we'll just have to keep check if p1 is equal to null. Okay, so in that case, if it is going to null, we are just going to assign the head of the second linked list, right? If it is not so, then what we can do, p1 will directly equal to p1 dot next. So we are just going to iterate. Similar way for p2, we are going to check if p2 is not equals to null. If it is null, then we are just going to assign the head of the first linked list, right? Else we are just going to the next node. That's all. So once we reach this part where both is become the similar one, right? Both node having the similar one, then we are just going to simply return at that time, right? So that will be our intersection point. So let's submit and see the test cases. Okay, my bad. This is ternary operator, right? I have given else condition first, then if. So that's quite wrong. Fine. Let me submit and see again. It will work, right? Yeah, so here you can see like our all three test cases got passed, right, and getting expected output. Now let's submit and see other test cases as well. Fine. So here you can see 41 test cases got accepted and reached 51%. Even it is current and optimal one at this stage. Okay, so yeah, if we talk about time complexity here, so as we are going to iterate for each element, right, or we can say size of n and m. N is the first linked list size and m is the second linked list size. So space complexity is going to be constant here because we are just using constant space, but in case of time complexity we are going to use big of m plus n, and m plus n denotes the size of the linked list, right? So yeah, that's all for today. If you know any better approach other than this 2-pointer, you can just comment down. Okay, so that's all for today. Let's see you next video. Bye.